today we're going to be talking about a new trade theory model. It's an increasing returns to scale model in a monopolistically competitive market. So why is this so different from the other trade models we've done up to this point? So think back to those three models, right? Ricardian model, specific factors, and Heckscher-Ohlin. What was true in each of those cases? Right? The one kind of common theme, or one of the common themes that came out of each case is that you had what we call inter-industry trade, which means that you would export one good and import the other. Right? Remember, those were all two-country models. If you had multiple goods, you would export some goods, import some others. But you never had cases, right? None of those models ever predicted a scenario where you would both import and export the same good. Well, the model that we're going to talk about today predicts exactly that, right? We predict what we call intra-industry trade. All right, so we've got this important distinction between inter-industry and intra-industry trade. And why is that important? Well, think about a lot of the goods that we consume today, they are characterized by intra-industry trade as far as international trade goes. You think about things like golf clubs, right? That's the example that you find in the textbook. We export and import golf clubs, automobiles, pharmaceuticals, right? All of these are great examples of products or groups, categories of products where we both are an importer and an exporter. And so why does that happen? Why would we want to, say, export some golf clubs and yet at the same time, obviously we're producing them, import them as well? Well, a key thing here is that what we're talking about is a good where we have differentiated products. Right? In other words, not all the golf clubs are the same. There's something different about the varieties of golf clubs that are being produced by the different manufacturers in different countries. Okay? Same thing with pharmaceuticals, same thing with automobiles. Really, any example that you can think of where we have intra-industry trade, we have some degree of differentiation, right? They have different features. It could be differences in quality, right? So it could be a kind of vertical differentiation, or it could be a horizontal differentiation. We just have different characteristics. And breakfast cereal is another good example of a differentiated good. So why is that important? Well, when you have goods that are differentiated, so they all have some characteristics that make them different from each other, but they're still pretty close substitutes for each other, then what that does is that gives this aspect of monopoly power to each variety of the good. And that's why we call this the monopolistic competition model. Okay? It's monopolistic competition. Okay? And if you think back to your principles of micro class, hopefully you covered this type of industry. But if not, just think back to the two types of industries for sure you should have covered: perfectly competitive and monopolistic. Monopolistic competition incorporates aspects of both. Okay? So we have some key assumptions here, right? Well, first off, because we have these differentiated goods, that's what gives us the aspect of monopoly. What does that mean for us? Well, if you think back to a monopoly, so a monopolist faces the entire market demand curve, right? And it's a downward, typically we assume a downward sloping demand curve. And what's important here is to think about the marginal revenue curve. Right? So what does marginal revenue look like? Now, for a competitive firm, marginal revenue was just equal to price. Right? Any firm can sell as much of the good as it wants at that price. So if I'm selling 100 boxes of cereal, and the going price for a box of cereal is $4. If I go to sell the 101st box of cereal, my revenue is going to go up by that $4. But that's not true for monopolistic competition. So what does marginal revenue look like in this case? I think the easiest way to think about this is just to make up a simple example. So let's say you start off with a price of $10 when you're selling 10 units of the good. Okay? And now let's say that you want to sell one more. You want to go to 11. Well, what's the first thing you should notice? You should notice that in order to sell that 11th unit of the good, you're going to have to drop your price a little bit. And let's say that that price goes down to $9.50. Okay? So the firm, in order to sell an 11th unit of the good, is going to have to drop the price to $9.50. Now we're assuming this is a single price monopolist, meaning that the firm is going to charge that same price across all units of the good. There's no price discrimination in this simple model. So what does marginal revenue look like in this case? Well, they're going to get $9.50 for selling that 11th unit of the good. Right? So that's our new price. But at the same time, they're going to end up losing 50 cents for each of the first 10 goods. And so what's that 50 cents? Well, that's the change in price that results from changing our quantity by 1. You multiply that by the initial quantity. So in this specific example, what does that look like? Well, what does that work out to? Marginal revenue is equal to the $9.50 that they get for the 11th unit minus 50 cents on each of the 10 units that they used to sell. Right? So if I highlight this in here graphically, right, that first term, that P, represented by this rectangle here, right, this is the increase in marginal revenue that comes from selling the 11th unit. And this one up here is the decrease in marginal revenue that comes from the drop in price that's required to sell that 11th unit. So what does that work out to in total? Well, so $9.50 minus what's the 50 cents times 10 comes out to 5. So in the end, you have $9.50 minus 5, which works out to $4.50. Okay? So in the end, marginal revenue is still positive, but it's much, much lower than that price at $9.50. So if I were to draw the marginal revenue curve, it would be somewhere like here. And this would hold true at any point along the demand curve, right? Marginal revenue is always less than the price, meaning the marginal revenue curve is lower than the demand curve. And so that's the important result here, or the fact that we get with these differentiated products giving a degree of monopoly power means each of the firms will face a downward sloping demand curve for its variety of the good. Now, this is a model of monopolistic competition which also includes increasing returns to scale of production. So what does that mean for us? Well, so you can imagine an industry where production is characterized by a pretty sizable fixed cost of production and a constant marginal cost as well. So what does that mean for us? Well, that means that from the firm's perspective, let's actually take a quick example here. So if we say that our fixed cost is 100, and we're going to have a constant marginal cost equal to 10. So if we go to produce different quantities here, 1, 2, 3, all the way down to 10, then what is the average fixed cost? If I'm only producing 1 unit of the good, then all of that fixed cost only gets split over 1 good. If I produce 2 units of output, I'm splitting that $100 of fixed cost across 2 goods, so that goes down to 50, 33 and a third, and here we get down to 10. Right? Now my average variable cost is just actually equal to my marginal cost, and that's a constant $10. So what is my average cost overall? All right, it's the sum of the two. So my average cost is equal to 110, 60, 43 and a third, 20, and so on. Right? So you can see as I increase output, my average cost is declining. So it looks something like this. I'm using a lowercase q there to denote that that's the firm's output, not industry output. You have something like this. Now what happens when we put these two things together, right? So you've got an industry characterized by monopolistic competition. So you have differentiated products. Each firm faces a downward sloping demand curve. And you've got this downward sloping average cost curve, right? Declining average cost. So what does equilibrium look like in this industry? Well, this is where you have to go in and incorporate the aspects of competition, right? We have free entry and free exit in this industry. So what does that mean? Let's start off with a scenario, and let's say that demand for this firm's variety is pretty high. So we have a relatively, say, small number of firms. So we end up with something like this. Okay. This is the demand for this firm's product. And marginal revenue is going to look, say, something like this. So the firm produces where marginal revenue equals marginal cost. So that's going to be its output. And then we go up to the demand curve to find the price. Well, what can we notice here? If you look at here, what we see is that price is greater than average cost, which means that profits are going to be positive. Right? Remember, you can write profit as price minus average cost times quantity. And what happens if we have positive profits? Well, that's going to induce other firms to enter the market. Right? We have free entry and free exit. So if these firms, the existing firms or the incumbent firms, are making positive economic profits, other firms are going to enter the industry. And what does that do? Well, that takes this demand curve and it shifts it down. I mean, think about it. You have a total demand that's out there for this product, total potential demand, but as more and more competitors come into the market, the existing firms will lose market share. Right? The demand for their variety will go down. And that continues to the point until the demand curve for the firm is just tangent to the average cost curve. And at that point, also marginal revenue would intersect right there as well. Okay. That's what we would end up getting, right? So you'd get firms entering the market, pushing the demand curve down. Now, what would happen if you had too many firms in the industry you'd get the exact opposite. You'd have a case where the residual demand left for each firm is just way too low. They're producing where price is below average cost. Firms would exit the industry, and the firm's demand and marginal revenue curves would shift up rather than down. And we'll illustrate that example when we work through this model when we open up to trade, because that's exactly what we'll see happening. Okay. So these are the basics. This is the setup for the monopolistic competition model. Next, we've got to take this model and embed it into a context where a country is going to open up to trade. Okay, so now that we've developed the basics, or hopefully for many of you refreshed the basics on monopolistic competition, depending on whether you covered that model in your principles of micro class, we now need to put this model in the context of international trade. So what we have here, again, downward sloping average cost curve, right? So again, increasing returns to scale, right? Constant marginal cost with fixed cost. D is the demand, right, in the total, for the total industry. The D over NA curve, that's the demand curve faced by the individual firm when all of the firms, all the competitors are charging the same price. And what is that D over NA? So NA reflects the number of firms in autarky. So D over NA, what we're saying is that each firm is just splitting, right, getting an equal share of the market since we're all charging the same price. This curve, D1, that is the firm's demand curve if it changes, unilaterally changes its price from what all the other firms are charging. So what should you notice here? You should notice that this D1 curve is flatter. So what does that mean? And think about that in the context of the elasticity of demand, right? D1 is flatter than D over NA, which means that it's more elastic. Right? Think about what that means if demand is more elastic. That means that consumers are going to be more responsive to price changes. Okay? And that's going to play a very key role in the analysis that's going to follow out of this. And so the last thing I need to do in here for you guys is we'll put in our initial equilibrium. Right, so our marginal revenue curve is somewhere like in here. Okay? And here's our equilibrium price, and in fact, I'll call this QA and PA, right? So that's our equilibrium in autarky. Now, what happens when we open up to trade? So what we're gonna make some important assumptions here. Okay? So now we're going to assume that the two countries are identical. Okay? And this is important for a variety of reasons. So first off, of course, it makes the analysis much simpler, but there's actually an even more important reason for making that assumption, and that is we want to focus on how this structure of the industry can lead to gains from trade. So in order to really focus on how having monopolistic competition with increasing returns to scale, and the latter part is key, how having an industry characterized by those two features can lead to gains from trade, we need to just make everything else, right? It's easy if we just make everything else between the two countries identical. And so here is the second thing that you should notice that makes this trade model very different from the preceding three trade models we covered in class. Now, if you think about the Heckscher-Ohlin specific factors, in each case there, we were looking at how differences between the two countries could be the catalyst and the driving force behind international trade and gains from trade. Here we're taking the exact opposite approach. Here we're saying that even if two countries are identical, they could still benefit from trading with each other. Right? That's a pretty important insight to have because, again, this is another dimension where the predictions from these new trade models differ very dramatically from the old trade models. Now, we've already talked about how the old trade models predicted inter or between industry trade. This model generates a prediction of intra or within industry trade. The other key distinction is that here we're saying two countries that are very similar to each other will trade. Whereas in the old trade models, the countries that were different from each other found benefits from trading together. So again, we have really important differences in the observed patterns of trade that can be explained. Right? So here what you're talking about is something like we refer to North-North trade. Right? Why does the United States trade so much with Canada and with the UK, with Germany, countries who are very similar to us in terms of level of economic development, how much skilled labor, how much capital we have, right, relative to other factors of production? These models are good at explaining why we trade with those countries, whereas those old trade models are much better at explaining why countries like the US, Canada, and Germany trade with lesser developed or lower income countries. Okay? And so as we continue to work through the course, I want you to keep that big picture in mind of comparing the old trade models with the new trade models. So if these countries are identical, what does that mean? Well, so here, when we say identical, we really mean identical. So same production technologies, right? So the average cost and the marginal cost curves for the firms in the home and the foreign country are the same. The demand curve is going to be the same. That also means that in equilibrium, NA, right, which is the number of firms in autarky, will also be the same. So what does that mean from an individual firm's perspective when we open up to trade? So if this D over NA curve, this reflects taking the total market demand and just splitting that evenly across all NA firms, and that gives us the residual or the demand curve for the firm when they all charge the same price. Well, what does that look like now that we've opened up to trade? Well, now demand is doubled, right? So if we look at this, what does the demand curve, the overall market demand curve look like? Well, we've doubled D, right? But at the same time, we've also doubled NA. We now have 2 times NA firms, at least initially, right, when we initially opened up the trade. So what does that mean for our D over NA curve? And so this curve, you can imagine, right, this goes to 2D, so now we might have a much higher aggregate demand curve. Okay. But D over NA is simply 2D over 2NA. So this curve actually doesn't shift, right? You can imagine if we had a market size where you're selling 1 million boxes of cereal a year and you've got 100 firms making cereal, right? So you split that 1 million boxes over 100 firms. Now when you open up the trade, well, we're selling 1 million boxes of cereal in the US and 1 million boxes of cereal in the EU, the European Union, but now you've got 200 firms competing to sell those 2 million boxes. So this curve doesn't shift. But what does change in here? You go back to this D1 curve. Now remember, D1 is the firm's demand curve when it deviates from that price, right? So if it charges a price different than what all the other in autarky 99 or now in trade, the 199 other firms are charging. Well, why would that change when we open up to trade? Well, it's exactly for that reason. We're now competing against more firms. And so think about it. Again, we already said that D1, right, it's flatter compared to D over NA. It's more elastic. So why was it more elastic? Well, there are 2 things going on, right? D over NA is downward sloping, right? Meaning that if everybody in the industry lowers its price, we're all going to sell more because consumers are willing to buy more at that lower price. But if I lower the price of my good and all of my competitors keep their price the same, not only do I sell more because consumers are willing to buy more at a lower price, I'm now able to steal market share away from my competitors who kept that higher price. Now, continue with that logic. Now when we have, instead of 100 firms producing, we have 200 firms, I can now steal market share not from 99 other firms, but 199 other firms. So that means that this demand curve will become even more elastic. Right? So it'll become even flatter. And that means the same thing, right? The marginal revenue curve will also become a bit flatter. So what does that mean? It means it might intersect somewhere like out here. Right? Call that Q2. So we have, notice the average cost is here, right? So I'm producing marginal revenue intersects marginal cost here, we produce at Q2. Average cost is here, but we go up to this new D2 to get the price. So what's happening here? Price is greater than average cost. Right? So if this were to hold true, great, the firm's now making positive profit. Right? Remember that profit is price minus average cost times the quantity. There's one problem with this analysis so far, though. Remember that all the firms are identical here. So if this holds true for one firm, this holds true for all of them. So if it makes sense for me to deviate from this original price of PA to try to drop my price to P2, steal market share, right, produce all the way up at Q2 at the expense of my competitors, it makes sense for the other firms to do the same thing as well. So what would happen if everybody follows that same path? What do we end up with? We end up with, instead of being on D2, we just end up, if we all charge a price of P2, we'd all end up right back on this D over NA curve. And so at this point here, so we'd actually end up producing Q3 at a price, at that P2 price, but now, right, average cost is up here. So if you look at this, and I'm just going to circle that for you guys, at that point, the price is below, P2 is less than average cost at Q3. That means that this is negative. That's going to induce firms to exit the industry. Okay? Really important to keep that in mind here. So again, individually, the firm has the incentive to try to lower price and steal market share. And if only one firm did that, they'd end up producing out at Q2 at that price of P2, which is higher than average cost. But since the same logic applies to all firms in the market, if they all drop their price to P2, then their sales would only be Q3, right? We'd read that off of the D over NA, or the 2D over 2NA curve. So that means that they actually end up producing at a loss, where price is less than average cost. So what's going to happen in this case? Well, remember, before we said if firms are making positive profits, that induces firms to enter the industry. But with free entry, there's also potentially free exit. So when some firms are making losses, some of those firms are now going to exit from the industry. So what happens in the long run? Right? So what we just showed there was our short run analysis. But what happens in the long run? Right? So initially, we have that 2D over NA curve there. Okay. What's going to happen to this curve as firms exit the industry? That 2D over 2NA curve that we had over here, and we'll go ahead and show I'll recreate in here the initial autarky equilibrium, right? We had that 2D over NA curve right in here. That curve is now going to shift out to the right because we have fewer and fewer firms over which we are splitting the market output. So that curve is going to shift out. Say it'll look something like this. And now we get this 2D over 2, call it NT, where NT is the number of firms in autarky, or in trade rather, in each country. Okay? And so what we're going to see is, right, so firms are exiting, so NT is less than NA. And this is going to happen in both countries, right? The home country and the foreign country. everything that we're seeing here, remember, the firms are identical, the demand, everything's identical in the two countries. So whatever holds true in one country is going to hold true in the other as well. So what happens when this curve shifts out? Well, now we're going to end up with, right, also the other demand curve is also going to shift out. And so we end up with an equilibrium that might look something like this. Right, so there is your, I'll call this dt for trade, and then the marginal revenue curve intersects somewhere out here. Okay. So you get something that looks like this. Okay. And then the price in trade would be here. Okay. So what are some of the things you can notice? Remember, before we had at our price up here. Right, that was our autarky price. Each firm produced QA at a price of PA. Now, after we open up the trade, right, so this was our short-run analysis here. And this here is our long-run analysis. Right, what happened in the short run? When we opened up the trade, firms said, hey, I can now steal market share if I lower my price from even more firms. They had an incentive to try to lower the price, but they all end up doing the same thing, which ends up causing them, right, when they drop the price to P2, to lose, end up having negative profits. The price 2 is less than average cost. So in the short run, firms were making economic losses. In the long run, firms exit from the industry. That causes, for the remaining firms in the industry, it causes these demand curves, right? This 2D, this one that's the share of the market, they all charge the same price. That one plus the individual firm demand curve, when it deviates from charging the same price, those curves shift out, those demand curves, and we get to a new equilibrium at a lower price and a higher quantity. And in fact, the two have to go together. So how is it that in the trade equilibrium, the firms can end up surviving at the lower price? Well, it's because we now have fewer firms splitting up the market, right? The existing firms have a higher market share. It allows them to move down their average cost curve. So they can survive at these lower prices because they're taking advantage of these economies of scale. Okay? So we have two really important things going on here at the same time, and they go in hand. So what does this mean from a welfare perspective? So if you think about it from a consumer perspective, we've already shown one very important thing that happens that benefits consumers. The price has gone down. Right? This is good for consumers. Because we have fewer firms competing, so they each get a larger market share and can work down their average cost curve, they're able to produce at a lower price. Definitely a benefit for consumers. There's also a second very important benefit for consumers from opening up to free trade, and that is an increase in the number of varieties that are available. At first, this might not seem quite that intuitive because we said, hey, we actually have fewer firms producing worldwide than we did before, which is true. But the key thing to keep in mind is that before opening up to trade, you can only buy the varieties that are produced in your country. So just to take an example, let's say that initially, I'll stick with what the example I started before, let's say that there are 10 firms producing in each country in autarky. And when we open up to trade, let's say that 3 producers fall out of the industry in each country. Well, so what's, right, NA is 10. 2 NA, the global number of producers is 20. But without trade, I can only consume the 10 varieties that are produced domestically. Then what happens when we open up to trade? Well, now, let's say I end up with 7 producers in each country, which means that globally there are 14 varieties being produced. With trade, I can consume any one of these 14 varieties that are being produced. So even though there are fewer varieties, right, fewer producers of the good, fewer varieties being produced globally, from any individual consumer's perspective, they have access to more varieties because they're no longer restricted to consuming the varieties produced in their country. And the notion here is that, of course, that greater variety is better. Now, there's two ways we can think about that. There's the love of variety approach, which simply says that, consumers like to have more varieties of a good. It gives them greater utility. One example I always like to think about here is like breakfast cereal. So if you eat breakfast cereal, let's say you eat it every day for breakfast, 7 days a week, 365 days a year. Now imagine that you have to consume the same cereal every single day for breakfast, 365 days a year, year after year. Now maybe for some of you, you're all right with that. But what if you could actually throw a second one into the mix, right? So maybe you can alternate which one you eat every day. Okay? Or what if you could choose from 3 different ones? So that's kind of this notion of love of variety, that even if I hold my level of consumption the same, as a consumer, I'm better off when I have greater variety available out there. Another way we can think about how variety benefits consumers is this notion of ideal variety. So we have love of variety, and then you have this notion of ideal variety. Okay. So imagine if there was only one type of automobile being produced, right? That's it. We all going to drive the same mid-size sedan in probably a medium gray or something like that, right? With all the same features, same horsepower, same cabin size, everything. Now that may fit some families, some households' needs well, but for others, it's not going to work at all. So what happens if we now increase the number of varieties? Well, now every household can find a variety that's a much closer to fit to what they're actually looking for. Okay? So that's that's a good example when you're thinking about how variety might benefit consumers. You could think of it either in terms of this love of variety. We like consuming different varieties of the same good, even for the same consumer, or an ideal variety, where the more varieties that are out there, any individual consumer is likely to find a variety that's closer to what they really want. Okay. So this wraps up the trade, what's the response in trade and how consumers and societies can benefit from trade, even when it's two identical countries trading with each other, if you have monopolistic competition with increasing returns to scale. The last thing I want to talk about in this lecture is a very important, really a workhorse empirical model in international trade known as the gravity model. So the last thing I want to introduce in this video is the gravity model. And as I said, this has become really a workhorse empirical model in international trade. And part of the beauty of the model is its simplicity. Now, first question you might have is, well, why are we calling it the gravity model? Simple answer is because it was lifted straight from physics, and it's the gravity equation, right? And so the idea is you take the basic equation from physics, that the force of gravity exerted between two bodies is equal to g, which is a gravitational constant, the mass of object 1 and the mass of object 2, all over the distance between them squared. Right? And so we could say that's the force exhibited between objects 1 and 2, or bodies 1 and 2. Right? And so we take this model, and it was actually an economist who was trained initially as a physicist, who saw and was familiar with this equation, and said, you know what, I think this might actually be able to explain patterns of trade. So we take this and we, of course, replace the F with trade, right? So trade between two countries, I and J, is going to be equal to some constant. And now it's not the mass of the two countries that matters, but we need something to represent sort of the economic weight of the two countries. So the most kind of common sense thing or the most practical thing we can think of is the GDP, right? The size economically of the two countries. And then it is the distance of the two countries. And here, we're raising it to some unknown power n, right? Because this is honestly something that it's an empirical, open empirical question, right? With the gravity model, we know it's the distance squared, right? But here we leave it's to some power n. And so this is the basic gravity model. Now, what's amazing is just how powerful it actually is. Now, when we go to estimate a gravity model, typically we don't estimate it in this form. We will talk about in class this empirical study that tried to get at an estimate for how much borders affect trade by actually estimating the model in this framework, and we'll talk about that. But most studies take a log transformation of both sides. And so what happens then is we write it as log Tij plus equals the log of b, so this just becomes a constant in the equation, plus beta I log GDP of country I plus beta j log GDP of j, and then there's that n, and then the log of the distance between I and j. Right? And this is the functional form that the vast majority of studies that are empirically estimating the gravity equation will work with. So why has this become such a workhorse model? Well, there's a couple reasons. One, even this basic equation really helps to explain the flow or the volume of trade between countries. So here, what is Tij? Well, Tij is often, listed as, exports from country I to country J. Right, so why is it that we export a lot to Canada, and then why is it that Canada exports a lot to us? Right, so if you think about Tij this way, there'll be two observations in your data set for US and Canada, exports from US to Canada and exports from Canada to the US. Other studies might do, total trade, in which case that pair of countries would have one observation. But regardless, if you think about this, so then why, usually we do it as exports from I to J, so then I is the exporting country, J is the importing country. So what we're saying here is, look, that the volume of trade between US and Canada, why is it so large? Well, the US is a large country. Canada's not as large, but it's not tiny. But then distance, right? We share a large border. Right? The distance is effectively, at some points, basically zero. Of course, this raises an interesting question of how do you measure the distance between two countries? Like, for example, what's the distance between the US and China? Well, what are you going to use? Are you going to use the capitals? Well, our capital is on the East Coast, right? Washington, D.C. But if you think about trade with China, a lot of those goods are coming into port, say, in Los Angeles. And that's where they arrive in the U.S. And that, California and the West Coast in general has a sizable fraction of our population and our economic activity. So it's not always clear how we want to measure distance. You have a big country like the United States, that's not a trivial question. But that's some of the more nitty-gritty details of how these studies happen. But this basic model it can go a pretty long way in explaining the differences in how much different pairs of countries trade. The other reason why this model is such a workhorse and is so powerful is its flexibility. Like, what if I want to get an understanding of how much free trade agreements affect levels of trade between countries? Well, because of this linear form, I can now add in another variable for whether countries I and J have a free trade agreement. I can add in other variables like whether the two countries have a common language. Why would that matter? Well, think about consuming cultural goods, right? Some of you might like watching BBC shows, right? They're in English. You don't have to read subtitles or have horrible dubbing, as is often the case with a lot of programs. It's a lot easier to read books, to watch movies, listen to radio programs, whatever, or podcasts, when you share a common language, common culture, things like that. These are all different things that different factors that we could then include into our model, and the model is very flexible. Now, I will focus quite a bit in class on one specific study that tried to use estimates of this b here, this constant right here, which in our log form is up here, to try to see how much having a border, right, an international border, affects trade.